So we are going to start about differential equation. And we first talk about what is differential equation, and then we talk about the physical meaning of differential equation and its formation and type of differential equation. Okay, so an equation which involves an equation which involves differential coefficient are called differential equation. And if we take a normal equation like 3x square plus y equals to 2, then it is a normal equation, as you know. But if it contains a differential coefficient, then or differential operator, then it forms a differential equation. If this equation 3x square plus dy by dx, as it contains a differential operator, now it turns out to be a differential equation. Okay, then now we talk about the physical meaning of differential equation. And the physical meaning is all about the differential equation describe a relationship between relationship between the quantity which is continuously varying with respect to another quantity which is continuously varying with respect to another quantity. Okay, then if we take an example like a bike travels some distance. If it travels some distance with respect to time, then we can assume a differential equation for that bike. Let we take a differential equation dy by dt minus at equals to 0, where a is a constant and y is our distance, y equals to distance, and t is our time, where the distance is varying continuously with time. As time goes on, the distance taken by the bike is varying. Okay, then if we want to solve the equation, it is the differential equation. Okay, we box it. Now the equation 1 is a differential equation. The equation 1 is a differential. The equation 1 is differential equation. If we solve the differential equation, how we can solve that? If we integrate both sides, then we can solve it. Then dy by dt equals to at, and then dy equals to at dt, and if we integrate both sides, then y equals to at square by 2 plus c, where c is the constant of integration constant, and here we also taken a is our constant which we initially given. Okay, then we box it and give it equation 2, where equation 2 is the solution of differential equation 1. Okay, differential equation 1, the solution equation 2 is the solution of differential equation 1, and here there is solution represent at the solution of every differential equation represent a family of curve. Is the here the solution of differential equation represent the family of curve. Now let's see how if we draw a graph using equation 2, then it will form like this. Here y and here t. If we take for simplification, if we take c equals to 0, then y equals to 80 square by 2, and the graph will like increases with t square like this. Okay, and as time never be negative, so we only stick with first quadrant. We don't go to the second quadrant, as time never be negative. Okay, then as t equals to 0, then the distance covered by the bike is 0, and as t increases, the distance is also increases, as the distance covered by bike is also increases. And if we consider if we take c, then the graph becomes like this. Okay, like this. As at t equals to 0, y becomes c, y equals to c. So there will be some distance, if t equals to 0, there will be some distance already traveled by the bike. So the graph is like this, and as we vary the constant, then we get different differential equation, as the solution gives a family of differential curve. Okay, then now we talk about the types of differential equation. Types of differential equation. And basically there are two types of differential equation. One is our ordinary differential equation, and another is partial differential equation. Ordinary differential equation, and another is partial differential equation. And in ordinary, what is the basic difference between ordinary and partial differential equation? The ordinary differential equation, it contains derivative with respect to single independent variable, while the partial differential equation contains derivative more than one independent variables. Like it contains derivative with respect to single independent variable, while partial differential equation contains derivative with respect to more than one independent variable. Let's take an example of ordinary differential equation and partial differential equation to visualize it. Okay, if we take an example, then it is very simple. Dy by dx plus, if we take 5x equals to b, where b is a constant, or we can take it as 3, whatever be the number. Okay, now the partial differential equation, if we take del f by del x plus del f by del y equals to lambda f, where f is a function of both x and y. So here the independent variables are x and y, and here del f by del x plus del f by del y equals to lambda f. Okay, then now let's see some identification of differential equation. Now look at some identification, how we identify differential equation. Okay, some terms related to differential equation. So we are going to see some terms related to differential equation. Okay. So first of all we have to see order and degree, these two terms of differential equation, order and degree of differential equation. And if you look what is order, and order of a differential equation is the order of highest differential coefficient present. Okay, we can write it as the order of the highest differential coefficient. Okay, and if degree is the power of the highest derivative term. Degree is the power of highest derivative term. Okay, so let's see an example. If we take an example, dy by dx cube plus 5y plus dy by dx equals to 0. Here the highest differential coefficient is 3, so the order becomes 3. Simple. Then now if we look at the degree of the differential equation, it is the differential equation, and if we look the degree of the differential equation, then the degree is what? The degree is the maximum power of the highest derivative term. The highest derivative term is d3y by dx cube, and the degree becomes 1, as the power of the highest derivative term is 1. So we can simply write it as degree equals to 1. And if we take another example, like 1 plus dy by dx whole cube to the power let dy by dx d square by dx square, and if we take square, right? Now here here also two differential operators are there, but one is it is the second order differential term. So here the order is, as it contains highest differential coefficient, so order equals 2, and highest differential coefficient power is 2, so degree is also 2. Similarly, if we take 1 plus dy by dx, in the same expression, if we take like this, and d square y by dx square, then if the differential equation contains any fractional power, then the first task is to convert the fractional power into an integral power. So if we take integral power, then we have to square both sides. Then the equation form like this: dy by dx and its whole cube equals to square y by dx square. It is the same expression as we did. So this differential equation have order 2 and degree also 2. Okay, So similarly you can do this, and now we already have seen that what is differential equation, as it contains a differential coefficient, and then we see that the physical significance, and then we talk about the identification of differential equation. And now let's move on to the formation of differential equation. Now we are going to look about the formation of differential equation, how we can form a differential equation from normal equation, and formation of differential equation. If we take a normal equation, like if we take a quadratic equation, y square equals to ax square plus bx plus c, then how we can form it a differential equation? By differentiating the equation we can get the differential equation. If we differentiate it, then what we get, 2y dy by dx equals to 2ax plus b. Okay, then if we further differentiate, then what we will get, 2y d square y by dx square plus 2 into dy by dx equals to 2a. Okay, if we further differentiate, then what we will get, 2y d square y by dx square plus 2 dy by dx square. Okay, equals to 2a. We write the same expression here, and now we differentiate it. If we differentiate, then 2y d cube y by dx cube plus 2 dy by dx into d square y by dx square. From this expression we get two terms, and then we get from dy by dx whole cube equals to 0, as it is a constant. So as we can also simplify it, right, like y d cube y by dx cube plus 2 dy by dx d square y by dx square. Sorry, there is no 2, as we remove all the constants, dy by dx whole cube equals to 0. This is the differential equation which we given by equation 2, and the solution of the differential equation is already given by equation 1. We make a differential equation from equation 1, and the differential equation shows that it is of the order 3, as the maximum number of maximal number of differential coefficient is 3, and the degree as the power of the differential coefficient, maximum power of the differential coefficient is 1, so the degree is 1. Okay, then we can also notice another thing, that it is the differential equation of order 3, and here also we take the equation 1 as there is a 3 constant, then the differential equation which forms have order 3. This is one thing we have to note it. And then if we take further examples, let's take another example of y. Let it take y equals to e to the power x a cos x plus b sin x. Then we want to make differential equation from this equation, so we have to differentiate both sides. If we differentiate, dy by dx equals to e to the power x and a minus a sin x, b cos x, and another term we get e to the power x, a cos x plus b sin x. Okay, then as e to the power x, a cos x plus b sin x, we can write it as y. This term becomes y, and we can write it as dy by dx minus y equals to e to the power x minus a sin x plus b cos x. Again we differentiate both sides, then what you will get, it is d square y by dx square minus dy by dx equals to e to the power x minus a sin x plus b cos x, and another term we get e to the power x minus a cos x minus b sin x. Okay, then this term is becomes e to the power x minus a sin x plus b cos x minus e to the power x a cos x plus b sin x, which is y, so we can write it as d square y by dx square minus dy by dx equals to and plus y minus a sin x plus b cos x. So we already get the value of e to the power x minus e to the power x into a minus a sin x plus b cos x here. So put these values here. So we get d square y by dx square minus dy by dx plus y equals to dy by dx minus y. So simplify it, we get d square y by dx square minus 2 dy by dx plus 2y equals to 0. This is the differential equation for which we can form from this equation, and here we have to note that it is order 2 and degree 1, and as the order is 2, so the solution of the differential equation must contain two constants. So here is the two constant and b, which the from as we can see that if there is two constant, then the differential equation is of order 2. Let's take another example, and we can see that if we take another example, and xy, if we take another example like xy equals to a e to the power x plus b e to the power minus x plus x square. So this is the equation given, and we have to find out the differential equation. So differentiate both sides. And again if we differentiate, as here if we differentiate a with respect to x, then we get dy by dx, and similarly here also dy by dx we get, and these add up and we get 2 times dy by dx, and a e to the power x minus plus b to the power minus x plus 2 we get. Now our basic aim is to remove the constant so that we can get the differential equation. So now the equation is here given, and if we put the values of a e to the power x plus b e to the power minus x, then we get x d square y by dx square plus 2 dy by dx equals to, here 2 is constant, and if we put the values of a e to the power x plus b e to the power minus x as xy minus x square here xy is there, and if we subtract minus x square, then we get the values of a to the power x plus b to the power minus x, and this is the differential equation we get. It is also of the order 2 differential equation, and similarly you can do different types of problems for the formation of differential equation, and in next session we will see the solution of the differential equation of various kinds of differential equation solution. And